So for this first lecture, we're going to be talking about Cbits and binary, which I'll explain the definitions of both in just a moment. This is just basic computing stuff, so it's just to give essentially a basis of the language that we'll be using when we jump into quantum computing, just to get an idea of the sorts of things that are fundamental to what we'll be talking about later on. So for binary, I'm sure that you've at some point in your life experienced, strings of zeros and ones inside a computer. Essentially, the binary system is a string of zeros and ones representing other units, other types of data. So for example, you might want to represent a number in base 10 in binary, which I'll show you a conversion in just a moment, and it's just a more efficient way of storing data, essentially. So in binary, we'll just start. The number 26 is represented by the string 11010. How do we perform this conversion? Well, in binary, what we do is we read the number from right to left. So 0 is the first, 1 is the second, 0 is the third, 1 is the fourth, 1 is the fifth, and then you kind of just keep going in that direction. For each of these, we have 2 to the power of however many it is from the left. So this is 0 from the left, this is 1 from the left, this is 2 from the left, 3, 4, and so on. So what we do is we multiply that 2 to whatever power by the number that's given there. So in this case, it's 0 times 2 to the 0, which is 0, 1 times 2 to the 1, which is 2, 0 times 2 to the 2 squared, which is 0, 1 times 2 to the third, which is 8, and 1 times 2 to the fourth, which is 16. So we add all of these up. You can see 8 plus 2 is 10, 10 plus 16 is indeed 26. So that's just a basic example of how we might use binary to express things. Now a note, we can tack on as many zeros to the front of this as we want. So 26 can be written either like this, 11010, or 00000111010, depending on how many numbers we're trying to store in whatever system that we're using. So this is a quick practice. I will ask you to write the number 144 in binary and to write the number 1100100 in base 10. I'll give you just a moment to work on that. So here we have the answers. 144 is 1001000 in binary, and of course you can put as many zeros in front of that as you'd like to. Just as a verification, this is the 1, 2, 4, 8, 16, so add that. 32, don't add. 64, don't add. 128, do add. You get 144 from that. And then same conversion process we used earlier. We get 64 plus 32 plus 0 plus 0 plus 4 plus 0 plus 0 is 100 in base 10. So now we're going to talk about addition in binary. So let's say we have two strings, 1, 1, 0, 0, 1, 1, 0, and we add the number 0, 0, 1, 1, 0, 0, 1. Well, in fact, it's just as easy as adding up the numbers in each column. So 1, 1, 1, 1, 1, 1, 1. And you can verify, actually, that this number here represents 102. This represents 25. And their sum is indeed 127, which is what this represents in binary. Now, for a more complex example, I'm just going to erase this. You may run into a case where you have ones in the same column, and I'll show you what you do in that case. So again, you start from the right. This, of course, is a 1. But this, 1 plus 1, is 2, and in binary, we actually express 2 as 1, 0. So 10. That's why there's this joke. There's only 10 types of people in this world, those that understand binary and those that don't. So that's just a little joke that you can have in your back pocket. But yes, indeed, this represents 2, and you can verify that. This is 2 to the 0, which is 1, and 2 to the 1, which is 2, and there you go, we got 2 in binary. Anyway, that means that we add this up and we in fact get a 0 here because that is the second place, the one on the right, and then you bring the 1 over here. Same thing, 1 plus 1, 10, 0, add the 1 up here. But now we have 3. Well, we represent 3 in binary as 1, 1, which means in this column, instead, we do 1, bring the 1 up here. Same thing, 1, bring the 1 up here. 1 plus 1, 10, 0, 1, 1. So if you need to go back and watch that, essentially what I'm doing, adding up by columns, if it's equal to 2, you put a 0 there and bring the 1 up, and if it's equal to 3, you put a 1 there and add a 1 up. Otherwise, you just do the normal sum. And like we did with the last example, you can in fact verify that these two numbers are 27 and 62. And when you add them, you get 89, which this represents in binary. So just to give a quick important term and important symbol, this means addition modulo 2. In binary, this is important because essentially anytime we have an odd number, addition modulo 2 will return a 1, and an even number will return a 0. It's just helpful for keeping numbers condensed. So that's all for this lecture. I will see you in the next one.